Okay, so I'll just take you through the introduction. So developing a software from scratch has become inefficient in terms of cost and productivity. And last week we highlighted why that's the case. The need for software reuse is justified. And the introduction of developing independent, flexible, reliable, and reusable components using the concept of component-based software engineering. So whenever I use the term CBSE, I'm referring to component-based software engineering, okay? So don't get confused. In this study unit, component models are discussed in detail, as well as supports which may be provided by using middleware on the models used. So we'll cover the following learning outcomes. So you should be able to demonstrate a detailed knowledge of the terms software components, which may be included in a program as an executable element. Demonstrate a detailed, thorough understanding of the key elements of software components models, and evaluate the support provided by middleware for those models. Demonstrate an understanding of key activities in the component-based software engineering or CBSE process for reuse, as well as the CBSE with reuse. Demonstrate an understanding of the three various forms of component composition and problems which may be encountered and how they are going to be resolved during the component composition of new components or systems. Okay, so now moving on to the next slide, we need to define what a component is. And we say that a component is an independently deployable implementation of some functionality. That phrase independent is very key. And in the next slide, I'll explain why. So for a software component, what it provides and requires should be clearly stated so that it can be used without any ambiguity. So it needs to be properly documented as to what are this particular component's inputs, what is its role, and what is its outputs. And in terms of technical terms, as you can see here in the drawing, this is how in terms of notation, we represent a component. Okay, obviously this is logical. This is not how components would look like in a physical manner, but this is a logical representation of a component. And what you can see from this particular logical or abstract drawing is that there is two interfaces. Okay, a component must at least have one of these interfaces. And we have the requires interface. What kind of information does the component need to do its work or to perform its functions? Remember, it's input, process, and output. And what does it provide for what kind of output does it provide for other components? Because output from one component can be used as input in another, okay? And when we talk about composition, you're gonna see how component composition. So these components, they communicate through a protocol which we call RPC, remote procedure calls, okay? The component does not have to be on the same machine as the particular software that's using it for reuse. It can be located on a different machine and downloaded at runtime. So they communicate using this protocol called remote procedure calls. Now, on that aspect of independence, there's a particular term we use in software engineering, which is called coupling, okay? So coupling is the indication of the relationships between the modules. So we're looking at the interdependence, okay? And so coupling shows the relative dependence and interdependence amongst the modules. While designing, you should strive for low coupling. Dependency should be between modules should be less loosely coupled. Components can be reused, okay? So what this is saying is, if you're going to be developing a software, make the components as independent as possible so to ensure that reuse can be done. You can see that there is actually two programs there in front of you now. And there is we can say it's the orange one or red if you like. And then we have the green one. So when it comes to the red or orange one, what we notice is that the component there's a high degree of coupling, okay? Which means they are dependent on each other. As opposed to the green one, where there's loose coupling and there is a level of independence. You can see now it's the same program still, but just coded with using different architecture. So we have the loosely coupled program in green, and this is good because if you wanted to reuse or build a calculator for someone else, all you need to do is take this particular class that says, sorry about that, is take this particular class that has all the functionality and incorporate it into the new software. It will not interfere with this particular display. And here it will have a rollover effect because if you decide to separate one, then it impacts on the whole program, okay? So when it comes to reuse, it's important that you consider the aspect of how loosely coupled are your components. So when it comes to CBSE, an approach to software development that relies on the reuse of entities called software components. It says that it's an improves on the object-oriented reuse since single object classes are too specific, okay? So when we look at the different levels of software reuse that we talked about last week, we said at the very top level, we have reuse of a system. When you talk about a system, we're talking about the whole ecosystem, which means there could be multiple applications within that system itself. So that's the highest level. Then we had a level lower than that, which is application reuse. We're reusing not the whole ecosystem, but one particular application. Then you have components reuse. And then at the smallest layer or the smallest level is object reuse. Now, we say CBSE is an improvement, okay? It's an improvement on object level reuse because object level reuse it's too time consuming, okay? If you picture a component has multiple objects, and these objects, we can say a text box maybe and a button. If you are doing object level reuse, you can imagine that you have to take all of those objects individually along with their code and copy it onto the new program that you're developing. But at components level, you sort of take the whole container, okay? So we can see how it's an improvement on object class reuse, which is too specific. And the goals, the whole purpose of CBSE is improved maintenance and upgrades, okay? Once you can separate certain layers of a software, it's easy to make changes. It's easier to make changes in the future. You don't want it that when you're making changes in the future and then it has a rollover effect and then the whole software is broken. So if you build it this way with loose coupling, then it's very easy to do maintenance or make changes. So elements of a components model. Now, when it comes to vendors that build software, they have to be compliant in terms of the way they actually build these components. And it says that are the standards that define how vendors should build components to ensure functionality, performance, reliability, usability, and other quality factors. So we're looking at the non-functional attributes of these components. How do you become compliant? And when you're building the component, you got to make sure that it has properly defined interfaces. Okay, we start there, and I said that in the previous slides. I said it has to have an interface. So you define your interface, your type of composition, and it has to be a provide and requires interface. Then also you have to provide metadata, okay? Stuff like naming conventions. Remember that you accessing these components remotely using the RPC protocol. So there has to be a naming convention so that you can properly reference, make reference to those components. And also it has to be well documented for support purposes, okay? So in terms of component vendors, they have to be compliant and look at all of these concepts when building components. Some of the issues that you may face when you're identifying which components to reuse, okay? The first one is trust. You need to be able to trust the supplier of a component. At best, an untrusted component may not operate as advertised. At worst, it can breach your security. So it may fail or it may compromise you. So you need to be wary as to where you get your components from. And I made this example of when it comes to a e-commerce website or system where payments need to be made. Now, if you outsource that component, that payment checkout page facility from an untrusted vendor, you can imagine what's going to happen to your customers, okay? It's a security breach, the credit card information, the payment details, all of that stuff will be compromised. So you need to make sure that you go with trusted vendors. And also in terms of requirements, different groups of requirements will satisfy different groups of components will satisfy different requirements. So you need to find out which ones are in line with the requirements or the specifications of the type of software that you are trying to build. And also the aspects of validation. The component specification may not be detailed enough to allow comprehensive tests to be developed. Components may have unwanted functionality. How can you test this? Will not interfere with your application. So components that are not well specified and defined in terms of the type of functionality they bring can have consequences on your software, because you may end up with functionality that is actually unwanted. And that particular functionality may be the one that's actually causing you problems later on. So you need to go through a process of validating to what extent does a particular component operate in your software? What purpose does it serve specifically? And then, so in terms of the CBSE process, it takes these two main forms. We have development for reuse, and then we have development with reuse. So when it comes to development for reuse, the development of two or more components or services meant for reuse. So here we're building we're building components for the process of reuse. And when it comes to developing with reuse, we're using components that have already been built to integrate them into existing services or systems, okay? So don't confuse the two. And if you see in the slide that follows, so CBSE starts from the time that a vendor decides to build a component, okay? So a vendor builds a component, and we refer to this as CBSE for reuse. Once they've built the component, it needs to be certified, okay? And obviously the organization that's certifying it has to either be local or external. Most of the time it has to be both, okay? There has to be an independent external certifier. But once you are done building that particular component, there is some sort of repository or component management system that you are required to upload your components on. And then from that particular platform, then the certifier can also access it in order to make the appropriate reviews, okay? Now, once your component is certified, it means now it is ready for the market, okay? And then other vendors, the components can be acquired by other people, software vendors, people building software, so they can incorporate it on their particular projects and use it. And then that flows into the whole process of CBSE with reuse. So you can see that CBSE for reuse, okay, flows into CBSE with reuse. One comes before the other. And this is the typical flow of CBSE with reuse, okay? So the component already exists, and we are now defining our specification for our software, and then we do an initial shortlisting of possible components that we can use. We modify our requirements according to the discovered component and according to the specifications, because sometimes you may be purchasing a component that provides enough functionality to cover some of the requirements that you had already specified. Okay, so you need to go back and modify your requirements accordingly. And then you move on and you identify your architecture. Okay, after you've identified or chosen the architecture, now you need to go back to your components again and filter out which ones will no longer be applicable in reference to the architecture that you are going with. And lastly, then you compose the components to create the system, or you integrate the components. So this is the typical flow for CBSE with reuse. Then the different methods of composition is what we're going to talk about next. And composition, in other terms, means different ways to integrate, or different ways that these components can integrate together. And we have these three main ones. We have sequential composition, we have hierarchical composition, and then we have additive composition. So let's talk about the first one. When it comes to sequential composition, a component is created from two existing components. Existing components must be in sequential order. This type of composition is the provides interface. And the reason why it's the provides interface is because component A, if you can see there by the picture below, component A has to first finish doing what it's doing, generate a variable. That variable can be used in the next process by component B. Okay, so it happens in a sequential manner. Picture a login component and a home page. Okay, so the home page has to wait for the login components to generate a session ID before it can load. That's one example of a sequential access of two components. And we have the hierarchical composition, and one component calls directly to another component. The calling component is the requires interface, and the code component is the provides interface. Okay, so with this one, there is some sort of calling that is done by component B when it wants to start doing or performing its functions. Okay, and there's an example here of a typical component diagram for, let's say, e-commerce shop. So we have the order component. Okay, the order component, before it can be fulfilled, will require information about the products, the customer who placed the order, and the account. Okay, so it will need to make direct calls to these components before it can be fulfilled. It will ask for stuff like, from the product component, it will call for the item code. It will ask for the customer's details from the customer's component. And then also it will require the account's details from the account's component. And then moving on to the last one, which is additive composition. Here we have two or more components together to create a new component. So it combines functionality of components A and B to create a new component altogether. And A and B are not dependent and do not call each other. Okay, we have these two, they're sort of working in parallel. Okay, they do not call each other, but they need each other. Let's take an example of Teams, Microsoft Teams, which is what is in front of us now. We have a component that's controlling the audio and a component that's controlling the video. Okay, so they are not dependent on one another. I mean, we can lose video and still have audio. Okay, sometimes we can lose audio and still have video. It happens. They're not dependent on each other, but when they work together, they give us the full picture of, or the full scope of the functionality. Because one can agree, if right now we didn't have the audio component, you wouldn't be hearing what I'm saying. So that's how this additive composition works, where we have two independent components coming together to form one new component. Okay. And then we do experience some challenges when it comes to composing these components. Okay. And when components are developed independently for reuse, their interfaces are often incompatible. 3 types of incompatibility can occur. So we have perimeter. We have perimeter incompatibility. Okay. And how this works is we have component B that's expecting an integer, but component A is generating a string. The 2 parameters that are being generated are different data types. So we have a problem there, and we have what we call a perimeter incompatibility. Then we also have operation incompatibility, and this goes back to the naming conventions. If there is a particular reference to a component using a remote protocol and the incorrect name is specified, then we want to have an operation incompatibility. Okay, and then we also have operation incompleteness, where the provide interface of one component is a subset of the requires interface of another. So component B was expecting a date of birth in the format of day, month, and year. But component A only sends, for example, the year of birth. Now that would have operational incompleteness. Okay, the output is incomplete for the next component to use it as input. So how do we address this problem? How do we address this problem? And we use what we call an adapter component or an adapter class. Okay, so an adapter class addresses the problem of component incompatibility by reconciling the interfaces of the components that are composed. So let me give you this example. We have 2 components here, address finder and mapper. Okay, and how these, yes. Yes.
Are you sharing your screen?
Am I not sharing my screen? Yes, I am. Can you not see?
No, I can't see.
Is anybody else also experiencing that problem? Can you guys?
I can see up
Can you see my
here.
screen?
Yep.
Okay, I think
I can also see us.
Yeah, I think I've also experienced that kind of problem on Teams. What you can do is, if you log off the meeting and you log back in again, it's usually solves the issue if nobody else is experiencing it.
All right.
Yeah, but we are about to conclude anyway, so you can maybe watch the recording. It'll also be helpful because you'll be able to see the diagrams that I'm making reference to. So we have these two components, okay? So we have component, let's call this one component A, address finder, and component B, which is the mapper. And how this program should work is that we look at a phone book database, we take the person's cell phone number, we put the cell phone number into the address finder. Then the address finder component, obviously, its role is to strip the residential address of the person from what we got in the phone database. And from that particular residential address, we then take it to component B, where a map is displayed of where the person lives. Okay, so that's how this program should work. But we have a problem because there is a incompatibility here, where let's say the mapper component or component B is expecting just the postal code. Okay, is expecting the postal code, and component A is generating a long full residential address. So let's just take that as an example, and in the next slide I'll demonstrate how the use of an adapter class can solve the problem. Okay, so we declare a variable address, and you say address is equal to address finder dot location with the cell phone number that's provided, and it strips that particular address. Okay, so the second line will demonstrate how an adapter class will work, because we have variable postal code is equal to this references a method in this particular adapter class, and it says post code stripper dot get postal code from where? From address. So it will take the full address and it will look for the postal code, and it will just strip only the postal code. And then now the mapper class is able to generate a map, okay, with the output from this adapter class, which is the proper inputs for it. Okay, so it takes away that issue of incompatibility. Okay, so that's the importance of using an adapter class. It works somehow like a middleware. So in conclusion, CBSE is a process of reusing components, and they are components. Components must communicate through well-defined interfaces, also using what we call glue code. Two services which are provided by a component, namely the requires interface and the provides interface. Okay, so that is component-based software engineering in a nutshell, and I'll provide you guys with some time to ask questions. So if you have a question, feel free to unmute yourself and ask.